Hello again. We're adding and subtracting rational expressions, but the problem is we can't add these two fractions together because the denominators are not the same. And we can't subtract these two because the denominators are not the same. Looks like the same problem, except one's got an addition, one's got a subtraction. In order to do this problem correctly, what you have to do is you have to get the denominators to be the same. And there's a couple different approaches to this. And it's not difficult teaching it. It's difficult teaching it so everybody understands it. That's what's difficult to try to convey. So I want these denominators to be the same. Basically, I want to figure out what number 8 and 24, what is the lowest common multiple of 8 and 24. And I'm sorry, 8 and 12. And in fact, it is 24. You know, 8, 16, no, 12 and 16 don't work. 8, 16, 24, 24 works, 12, 24. Well, that's easy to say, but not easy to do. And this has x squared and this has 12x cubed. Let me show you the way I started teaching it some time ago. And it depends on the class. Different people just learn in different ways. But what I tell my students to do is this. I want you to prime factorize this denominator, just in case you don't know. If you do know it's 24x cubed off the top of your head, great, move on, fantastic. But if you don't, here's what you do. So I got 8x squared. What I do is I split it. 4 and 2, 2 and 2. X squared just splits into x and x. So when I prime factorize 8x squared, I got 2, 2, 2, x and x. Okay? When I prime factorize the 12, I get 12x cubed, pardon me. 4 and 3, 2 and 2, and 3 x's. Okay. I'm trying to get both denominators to be the same. So here's what I know. I need everything that one has, the other one has to have the same thing too. So I'm going to show you this prime factorization really quickly, and I'm going to rewrite it. Now some of you might find this confusing because you're going to do the simpler way. That's great. Not everybody can do that way though. So 9 over 8x squared is the same thing as 2 times 2 times 2 times x times x. That was the prime factorization. Plus 5 over 3 times 2, 6, 12 times 3x's. Now, I want the denominators to be exactly the same. Well, this one has 3 2's, this one has 2 2's, so this one needs another 2. This one has a 3, this one doesn't have a 3. And this one has 3 x's, this one has 2 x's, so you got to put another x there. So the LCM of both of these, or the least common denominator, least common multiple, lowest common denominator, is, let's see, 3 times 2 is 6, times 2 is 12, times 2 is 24, x cubed, and that's a 9. This one is, well, no. Pause there for a moment. This one comes out to 3 times 2 times 2, which is 6, 12, 24. X times x times x is x cubed. So my denominators are the same. But I multiplied a 3 and an x in the denominator of this fraction. So what I do in the denominator, I got to do in the numerator. Comes out to 27x. And I multiplied a 2 in the denominator, so I got to balance it out by multiplying the 2 in the top, which is 10. Now I can add these fractions together. So I have 27x plus 10, and the denominators are the same. So I got 27x plus 10 over 24x cubed. That's a very brutal way to do it. And I wouldn't do it this way normally. What I would do is something else. But I just wanted to show you where I was coming from there. That is an approach you can use. Let me show you a different way now. I'm going to erase. Here's what I would do instead. I know this one has 3 x's, this one has 2 x's, so this one needs another x. Okay, simple. Done so far. This one is an 8, this one is a 12. What number do they both go into if I keep stacking them up? What's the smallest number they both go into? Well, this one's 8, This one's 12. Okay, that doesn't work. The next number after 8, when I multiply it by 1, by 2, by 3, by whatever, is 16. That doesn't work, 16 and 12. Next one is 24. 24 doesn't go into 12, but if I do 12 times 2, that's 24. So I know that they both have to be 24. Okay, well how do I get a 24 on 8? I multiply it by 3. How do I get a 24 on 12? I multiply it by 2. That's actually what I would do to do it. A lot simpler. If your mental math is good, you can do it. If it's not, that's a problem. So I got 9 times 3 times x is 27x. 8 times 3 is 24, x cubed, plus 5 times 2 is 10, over 24x cubed. My LCD or my LCM is 24x cubed. That's the denominator that I need in order to add these bad boys together. 27 x-men plus 10 people is just 27 x-men plus 10 people. Now the argument people are going to have is, well, why don't you just teach it that way? Because I can't. Because some people can't do it that way without a little bit of guidance first. So it's something that you have to realize. If you know your multiples, it's very easy. The variables are easy. This has 2, this has 3. Just, if this has 3 and this has 2, just put another one so they match up. This is an 8 and this is a 12. Figure out what number, what's the least common multiple of both those numbers in order for it to work, which is 24. And then what you do on the bottom of a fraction to manipulate it, you do on the top of a fraction. Bottom of a fraction, you do on the top. These are expressions, by the way. With equations, the process is different. Okay, well that was an addition problem. This is a subtraction. I know what I need the denominator to be. I need it to be a 24x cubed. I already figured that out on this last problem. These are exactly the same. How do I get a 24x cubed? I multiply by 3x, multiply by 3x. That would give it a 24x cubed. What do I need to get a 24x cubed here? Multiplied by 2. But what you do on the bottom, you do on the top. So I got 27x, 24x cubed, subtracted by 10 over 24x cubed. 27x subtract 10, can't do anything there, over 24x cubed. We got plenty more to do. In my opinion, if you're not bad with factoring, these are the worst types of problems to do. But if you don't like factoring, then that's the worst type of problem to do. Not all of them are as difficult as this, and you kind of just punch through the motions, and you really do get better, but you have to practice. If you're just going to quit, then you're not going to get better with it. You got to keep going with it. You got to keep practicing. But that's the theory on how you would, solve it. One of two different ways. You could, split it up and figure out what you need, or you can just kind of do mental math there. And mental math can be sometimes very difficult for students. That said, we're going to do another installment of this, actually maybe 2 more. See how it goes. Have a good day for now. Goodbye.